Hello, friends. Welcome to Applied Math. Daily lesson number 1 here today. We're going to walk through our notes, 7 example questions, and then we'll give you some time to do some practice work on your own. Today we're going to look at single variable equations and isolating variables using inverse operations. So remember, our inverse operations we'll be dealing with here. Operations that negate or cancel each other out are addition and subtraction, multiplication and division, along with square and square root. So think if you want to start with a given value, easy number like 100, if you add 10 to that number and then want to undo adding 10, you would subtract 10 to get back to that 100 value. Multiplication, if you take 100 and multiply by 2 to get to 200, well, to get back from 200 to 100, you would have to divide by 2. If you square a number, 6, and square it, you get to 36. To get from 36 back to 6, you take its square root. So our goal here, looking at the first 3 examples before I put up 4 through 7, we are going to use inverse operations to get the given variable alone. So, example 1, I have 5x minus 12 is 28. Again, my job is to get the x variable alone. So first thing I'm going to do is move non-variable terms to the other side. So I will undo subtracting 12 with adding 12 to both sides. Again, the plus 12 minus 12, that makes 0. Those will cancel out. I'll have my 5 times x is equal to 28 plus 12, 40. Now to undo multiplying x by 5, I'm going to divide both sides by 5. Don't forget the golden rule of algebra. What you do unto one side of the equation, you must do unto the other. So dividing 5 by 5, I get 1x equals 40 divided by 5, which is 8. If you're unsure, you can always, remember, plug in your x equals 8 into your original equation. 5 times 8, 40. 40 minus 12 equals 28. Boom goes the dynamite. Taking a field trip over to example 2. Notice here I have 2r variable terms on the left side. So I'm going to combine those two together. They're not on the opposite side of the equal sign. So those are what we call like terms, and I'm going to put those two together. So if you start with 4 r's and take 6 away, you're going to be left with negative 2 r's equals negative 12. Last step here is to get the r alone. I'm going to undo multiplying it by negative 2, so I'll divide both sides by negative 2. And I'm going to have r equals positive 6. Feel free to check that if you are unsure. 4 times 6, 24, minus 6 times 6, 36. 24 take away 36 is a negative 12. Example 3, look out. This is a kind of a special example. We have 2/3 times y equals 36. Now here I am dealing with a fractional coefficient value. A coefficient, again, is just a number or value in front of a variable. So I have 2/3 times y equals 36. So you're thinking, ooh, I've got y being multiplied by 2/3, so I should divide. Wrong. Fractions, recall, you need to multiply both sides by what we call the reciprocal of that coefficient value. So in this case, the reciprocal of 2 over 3 is 3 over 2. So that's what I'm going to multiply both sides by. 3 over 2, so 36 over 1 times 3 over 2. Any number times its reciprocal, 3 times 2, 6, 2 times 3, 6, is 1. That's the reason why I multiply a fraction by its reciprocal value, to isolate the variable. I'm going to have y equals, I can reduce 36 over 2 is 18 over 1. So I have 18 times 3 is 54. So 54 over 1. Got the first three examples down. We're going to take a little pause here. I'm going to get examples 4 through 7 up momentarily, and then we will work through those. Thank you so much. Let's keep rocking. Alrighty, friends, we are back like a bad rash to look at examples 4 through 7 here on daily number 1. Example 4, notice here we have our old friend, the F word, a floater, this minus sign outside this binomial of y minus 4. This is the same as a -1 being multiplied into the y and the minus 4. So I'm going to multiply both the y and the minus 4 by -1, in a sense taking its opposite. So -1 times y, -1 times -4 is positive 4. And I still have plus sweet 16 equals -33. Left side, I have the like terms here of 4 and 16. So I'll have -y plus 20. This will equal -33. Subtract 20 from both sides. I'm going to have -y equals -53. So this is like a -1y equals -53. I'll divide by -1, and positive y will equal positive 53. Groovy. Example 5, that's 5 if you're a non-Spanish speaker. We have 1/2 h plus 1/4 h equals 34 minus 2 squared. So a couple things we can do surgically on both the left and the right side of the equation. Let's get the ugly one out of the way first, combining my h terms. Whoa! Our fractions, however, are uncommon denominators. So we need to look at my denominators of 2 and 4 and think of their least common multiple, the first number that 2 and 4 both go into. Yes, that is quattro, 4. So I'm going to multiply 1/2, top and bottom, by 2. So I'm going to have 2/4 h plus 1/4 h will equal, right side, I can keep my 34 minus 2 squared is 4. So going back to the right side here, 2/4 and 1/4 would make 3/4. So 3/4 h will equal 34 minus 4 is 30. Here we are again, friends, with a fractional coefficient. So I'm not going to divide to undo multiplying a variable by a fraction, but I'll multiply by its reciprocal. 3/4 multiplied by 4/3, so 30/1 times 4/3. Any number times its reciprocal is 1, so I have 1h will equal, I can reduce 30 divided by 3 is 10/1, 10 times 4, 40, over 1 times 1 is 1. So 40/1, I'd have h is 40. My last two examples here, I have a kind of an ugly left side that I need to clean up here first, and then a what we call the special start example here for daily 1's finale. Left side of example 6 on -3 plus 3 times the quantity of -1 minus b is 24. I need to first get rid of my parentheses using the distributive property. So I'm going to have -6 plus 3 times -1, -3, and then 3 times minus b, -3b. That'll equal 24. Left side, my like terms, -6 and -3, -9 minus 3b will equal 24. I'm going to add 9 to both sides. -3b will equal 24 and 9, 33. Divide by -3, and b will equal -11. Last one. This is kind of a two-step process here. I am going to give you a true statement. If 7z minus 19 is 30, I then want you, me, us, to find the value of negative 2 times z minus 1. So I need to think of this as a two-step process. First, I am going to take the given equation, in this case 7z minus 19 equals 30, and solve it. So I'm going to get z by itself by first adding 19 to both sides. I'm left with 7z equals 49. Divide by 7, divide by 7. I'm going to have z equals 7. Halfway done. Yes, we found the value of z equals 7, but I am asked to find the value of negative 2 times z minus 1. So here's what I'm going to do. I'm going to take z equals 7 and Glade air freshener, plug it in for z right next to this negative 2. So I'm going to take negative 2 times z is 7 minus 1. So negative 2 times 7, negative 14 minus 1, negative 15. So I'm going to double box negative 15 because that is the final answer to finding the value of negative 2z minus 1. Thanks for your focus and dedication. It's time to blow up questions 1 through 20.